In this video, we will discuss about find kth bit in nth binary string. Given two positive integers n and k, the binary string Sn is formed as follows. Return the kth bit in Sn. It is guaranteed that k is valid for the given n. So what they are saying is that in the input, we are given two integers n and k. We need to find out what is the kth bit in nth binary string. Right? Now what is nth binary string? So in the question it is mentioned that s of 1 is equals to 0. Right? Then for every n, s of n will be equals to s of n minus 1 plus the bit 1 plus the reverse of invert of s of n minus 1. Right? So if I say my s1 is 0, then what will be s2? S2 will be s of n minus 1, that is s of 2 minus 1, which will be s1. What is s1? 0. So for this it will be 0, right? Plus the bit 1. So we will have 1 here. And then reverse and invert of s of n minus 1, right? What is s of n minus 1? 0. What will be its invert? Invert means that we are flipping the bits, right? 0 to 1 and 1 to 0. So this is our s of 1. What will be its invert? 1. Right? And then what will be its reverse? 1 only, right? So this particular expression is 1 in this case, right? So it will be 1. Then if we check for S3, then for S3, again it will be S of 3 minus 1, which is S2. What is S2? 0, 1, 1. So it will be 0, 1, 1. And then this bit 1. So again 1. And then reverse and invert of S2, right? What will be the invert of S2? 1, 0, 0. And what will be its reverse? 0, 0, 1. Right? So it will be 0, 0, 1, right? Then what will be S4? S4 will be equals to first S3, which is 0, 1, 1, 1, 0, 0, 1, right? Then the bit 1, and then what will be the invert of this? 1, 0, 0, 0, 1, 1, 0. Then what will be its reverse? Its reverse will be 0, 1, 1, 0, 0, 1, right? 0, 1, 1, 0, 0, 1. This will be S4, right? And so on, you can calculate. Now they are saying what is the kth bit in nth string. So let's suppose n is given as 3 and k as 2. Then you need to find out that what is the second bit in S3, right? Which is 1. So you need to return 1 as your answer, right? So now if you closely look here at all these strings, let us try to find out their length and the relation between them. So for S1, the length is 1. For S2, the length is 3, right? For S3, it is 7. For S4, it is 15, right? Now, how can I identify the length of S4 with the help of length of S3? If you see here, for building Sn, we are using the previous string, we are adding a bit 1 to it, and then we are again using the previous string in some form. We are doing the invert of it and we are reversing it. So whatever is the previous string, that is being inverted and that is being reversed. So after these two operations, is the length of this s of n minus 1 going to change? No, right? Because we are only inverting and reversing. We are not adding or removing any bit. So can I say that whatever is this length will be this length, and these lengths are equals to the length of s of n minus 1, right? And we are just adding one extra bit to it, right? So can I form this relation that the length of s of n will be equals to 2 into length of s of n minus 1 plus 1, right? We can say this as well. Now, if you see here, can I write this one as 2 to the power 1 minus 1? What it will be? It will be 2 minus 1, that is 1, right? Then can I write this 3 as 2 to the power 2 minus 1? So this will be equals to 4 minus 1, which is 3, right? Can I write this 7 as 2 to the power 3 minus 1? It will be 8 minus 1, that is 7, right? Then can I write this 15 as 2 to the power 4 minus 1? So it will be 16 minus 1, that is 15, right? Now if you closely look that for S1, the length is 2 to the power 1 minus 1. For S2, it is 2 to the power 2 minus 1. For S3, it is 2 to the power 3 minus 1. That means we can generalize this to that the length of Sn will be equals to 2 to the power n minus 1, right? Can I say this? Because When you had 1 here, its length was 2 to the power 1 minus 1. When you had 2 here, your length was 2 to the power 2 minus 1. Right? So the length of any string, the length of any nth binary string will be equals to 2 to the power n minus 1. We will take this point forward and we will try to solve the question. Right? So now let's remove all this now. So now let us suppose that in the question it is given that n is 3 and k is 2. Right. Now what was the third string? I'm just writing S3 to explain you. We won't be creating the string in our solution. Okay. So it was 0, 1, 1. The middle bit 1 and 0, 0, 1. And if I give the indexes, it will be 1, 2, 3, 4, 5, 6, 7. Right. So now I said we won't be creating the string. Right. Because if we'll create it, then it will hamper our time complexity and space complexity. Right. So instead, I know that the length of this string is 2 to the power n minus 1. Right. N is given as 3. Then that means the length will become 2 to the power 3 minus 1, which is 7. Right. Now I know the length, I know the k. Right. So what you need to check is, with the help of length and k, you need to find out whether this k is pointing to the middle bit or not. Right. If your k is trying to find out the middle bit of Sn, then it will always be 1, right? Because we are always adding a bit 1 here. So whenever your k is equals to the mid of your current binary string, then you can simply return 1. You know the bit is always going to be 1, right? Now when it is not equals to the mid, there are two cases. Either your k will be less than mid or it will be greater than mid, right? When it is lesser than mid, then it will lie in this string, right? Now what is this string? This string is nothing but S2, right? That is S of n minus 1, right? So now your problem reduces down to finding the kth bit in n minus 1th string, right? You saw that your k is lying in this range, right? So, and this is the previous string. So now you will have a recursive call for this, and then your n will become 2 now and your k will remain 2, right? And then again you will check for the string, you will identify its length, you will check whether the k is pointing to the mid element or not. If it is, then you will simply return 1. Otherwise you will check whether it is lying in the starting or ending, and accordingly you will do. So now if let's suppose our k was 5, in that case it would lie in this string. Now what is this string? How you will make a recursive call for this one? So this string is also s of n minus 1, but it is just inverted and reversed, right? So my question is, this string before reversing, it would have been 1, 0, 0, right? Forget about inverting right now, just focus on reversing. So this string before reversing would be 1, 0, 0, and after reversing it is 0, 0, 1. So if you see the indices here, 1, 2, 3 and 3, 2, 1. So if let's suppose this was before reversing, right? You needed to find the bit 1. You needed to find the bit at the first place, which was 1. So before reversal it is okay. Now after reversal, what will happen is that the first bit will go at the last, the second bit will go to the second last, the third bit will go to third last, and so on, right? So if here I am finding out the kth bit from the starting, then that means in the reversed form I should find the kth bit from the end, right? Because it is in reversed form right now, right? So whenever our k lies in this range, in that case we will keep n as n minus 1, but our k will change. K will become length minus k, right? Because now we want to check from the end, right? And now what about the invert? So whenever you know that your k was lying in the second half, then that means it is reversed and inverted. So for reversed, you changed your k. Now from this recursive call, whenever you get any bit, let's suppose you got 0 as your answer. Now you know you were in the second half, it would have been flipped. So when you got 0 as the answer, you will return 1. And if you got 1 as your answer, then you will return 0. So this is how you would be able to handle both reverse and inverted case, right? So I hope you got the intuition here. So now another thing that we need to see is, for this S3, what is the middle bit? This one at the fourth index, right? What was the length of this S3 if we calculate using this formula? So it was 2 to the power 3 minus 1, that is 7, right? How will you find the mid? You will find out by doing length by 2, right? So you will do length by 2, which is 7 by 2, which will give you 3, right? But is this 3 the middle of our string? No, right? This 4 is the middle of our string, right? So instead of calculating the length with the formula 2 to the power n minus 1, we will only calculate the length as 2 to the power 3 or 2 to the power n. So here it will become 8. Now when you will do length divided by 2, that is 8 by 2, then you will get 4, which is the exact middle bit of your string, right? So for finding out the correct indices of the bits, that's why we are removing minus 1 from our length, right? And then now in this recursion calls, what will be your base case when you will stop? In every recursive call, we are doing n minus 1, n minus 1, n minus 1, right? So what will be the base case? There will be a point when n will become 1, right? For n equals to 1, we know that the string is 0. So this becomes our base case, that if in any case our n becomes equals to 1, then we can simply return the bit as 0, right? So this will be our base case. So now let's code it out. So first of all, we will identify the length of nth string, which will be equals to int length equals to 1 left shift n. So this is equivalent to 2 to the power n, right? Because left shifting by n is equivalent to 2 to the power n, right? Now when we have find out the length, we need to check where is k present. So if your k is present in the starting string, that is if k is lesser than length by 2, or we can say the mid, right? Length by 2 is nothing but the mid. So if k is less than mid, then that means we are reducing down the problem to finding out the kth bit in n minus 1th string, right? So we will call this function again. We will return and call this function with n minus 1 and k, right? Now if your k is equals to the middle element, right? If it is equals to the middle element, then you can simply return 1, right? Because at the middle, always the bit 1 is present. Else, when your k is greater than length by 2, then that means it is lying in n minus 1th string, which is reversed and flipped, right? So this will return as a character, this recursive call. So let's take inverted here. This will return as inverted character, right? We'll call this function n minus 1, and what will k now? It will be length minus k, right? Because our string was reversed. So now we have to find the kth bit from the end. That's why we are doing length minus k. Now this will return us the inverted bit. So we will check that if the inverted bit is equals to 0, then that means we need to return 1. Otherwise we need to return 0, right? Now what will be the base case of this recursion? The base case will be that if at any point your n becomes 1, then what is your string? Your string is 0. So you will simply return 0, right? So let's run this now. So it got accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.